Hello and welcome to one of my newest tours of my good friend Chad Shapiro's unbelievable collection of early electrical lighting and associated transmission technologies. Hands down, this is probably the best collection of its type in the United States in private hands. And we're going to start with a little look-see with some of the early lighting fixtures, meters, and right in front of us, the Edison Type R machine that Chad was lucky enough to procure maybe 3 years ago.
Yeah.
From a Philadelphia collector that's been around forever. Who Shallenberger Meter on Facebook. But, in many ways, wouldn't you say this is kind of the second model or third model after the long leg or long waist of Marianne? Is what came in sequence after that?
Yeah, so there are a couple of variants of the long waist of Marianne, like between 1879 and 1882-3 era. This is kind of a transitional form between this and what's known as the Hopkinson style, which is your sort of your we'll call common, if you will, Edison Dynamo. The poles were still much taller. The pulley in the back was still integral with the armature, so it was not an interchangeable piece. And for the most part, you see some things where the base is sort of, again, transitional. It looks in the form not of a long waist of Marianne, but of a Hopkinson. It very much is a hybrid and transitional form. And they actually made these for a very short period of time. There are only two of these known to exist. There's this one, which was formerly from the collection of Henry Ford, who was sold in 1985 at auction for a very low price. Wish we could have been there. $800, and it could have been yours in 1985.
Right, I have a number of fans that came out of there, like Phil Longa, Phil Lang fan, and things like that too. So it's amazing what the Henry Ford has ended up in the hands of private collectors.
Yeah, we won't get into values here, but that's just kind of a fun little factoid, because things surely have changed. But remember,
only to us, few limited people, is an electric motor or a dynamo something really significant. It's a big, heavy object.
Yeah, it's about 1,500 pounds.
Right. And I think there was a 75 kilowatt dynamo, the one that was in the Henry Ford, or was it bigger than that?
80 kilowatt.
80 kilowatt. Yeah. But what's interesting to me here, though,
17,000 pounds.
Right. And so I guess you had Pearl Street, you had the Vulcan rubber mill, or not rubber mill, paper mill, rather, in Appleton, Wisconsin in '82. And 2 years later, this would have been something with a small, remote generating factory.
Right. A factory, or you could have certainly lit a few houses with this. This machine's rated for 60 kilowatt-hour average-sized light bulbs. So it was very common. If you look at the earliest Edison meters, they started out as rated for 6 light bulbs. We'll look at those in a little bit. So when people first started electrifying their homes, they didn't switch over completely. They would put some light bulbs in their foyer, in their dining room, entertaining areas to show off the newest technology to their friends. And this could have fed 5 to 10 households with light bulbs, or it could have been used in a factory type application. In fact, the other known example, which is at the Menlo Park, Edison Center in Menlo Park, we shout out to them, our friends at the Menlo Park Center. They have the other example. I believe theirs was found in a factory. And while demolishing that factory, within the last, I think, 10 years or so, a very smart person grabbed it from the scrap pile and donated it to their museum.
Well, it's amazing. I mean, many universities have examples of Edison Dynamos in their collections. I mean, I've personally seen a long waist of Marianne dynamo at a university near me, and it's amazing to think this was something left to the electrical engineering departments.
Right. In many cases, they hadn't since they were new.
Right. I mean, I think that's certainly true. Now, was the Gourmet construction of the kind of a Gourmet rotor, was that one of the things that Edison absorbed?
Well,
how would it differ?
I'm much more of a historical collector when it comes to the technical end of all this. It goes a little bit over my head. Edison's first dynamo that he bought was a Wallace Farmer, which was designed by Moses Farmer and William Wallace, who had developed an arc system prior to Edison's lighting system. That machine has a very similar armature to a Gourmet. So Edison would have started with a machine very much based off of the Gourmet, which really was, as far as I understand it, revolutionary to...
In 1872, the A-frame Gourmet was dynamo. I mean, traditional or Russian commutator construction like we think of today, plus of course, you know, more than anything, the use of a quadrupole setup, you know, which was essentially would function, I think, like two poles. I'm not sure if you like.
I think each two were in series.
Right. So it functioned like a bipolar motor.
Or in parallel.
Yeah, Siemens and Wheatstone prior to that had experimented, but Gourmet was the first to really revolutionize it in a commercial sense. So.
Yeah, when you start to look at this armature, and again, I'm very Edison focused, and this certainly, there's always more research to be done, but very much this is a design that where Edison made that armature longer, made the coils higher. So in true Edison form, Edison didn't invent the dynamo by any means, but he took existing technology and improved it to work best for his use, which in this case was electric light.
And you know far more about the meters and, of course, the switches. Obviously, early Bergman stuff here, for my limited knowledge. But what can you tell me about some of the fixtures, some of these pieces?
Yeah, so this represents some of the ancillary equipment you need to go along with this dynamo. We have our amp meter, which would measure the draw, make sure we weren't pulling too much resistance on the machine.
Right.
This is a little bit later piece. This is a pressure indicator, which they called voltage at the time, pressure. This was a piece that was designed, you can't really see it here and the lighting's not great, but there's actually some gilded design on the cast iron base. This was designed to be a much less utilitarian. I mean, all the stuff that they made back then was beautiful, but this was really designed, you have beveled glass here. This was designed to go in, say, the kitchen, where your help in your home could use this to monitor the incoming electricity, either from your local isolated plant, say a machine like this in the basement, or a central station, to make sure the voltage was correct. And if the voltage went over, one of the light bulbs would turn on.
And you're the light bulb man. What can you say about the bulbs here?
These bulbs are from the era that this unit is made. So between 1889 and 1891, which is the era of Edison General Electric. So these are the appropriate bulbs of that era. And
are these both Bergman fixtures right here?
Yes, these are. This Bergman fixture actually came from Stefan. This is it is shown in the Bergman catalog. You'll see the space is the Bergman design. This Bergman fixture is patented based on this swivel mechanism. So this is insulated in hopes that the early wiring wouldn't wear in there and short, and then make this conductive and very dangerous.
But you know, maybe we should mention why Bergman's so important, because they were the primary maker for Edison of early, lighting fixtures. The second or third electric fan sold commercially in the United States, more likely the third. And they really did a lot of the hardware manufacturing for Edison.
So Bergman originally worked for Edison in Newark, New Jersey, as a machinist, and he was a master machinist. By the time Edison was at Menlo Park, Bergman had started his own precision manufacturing firm making scientific instruments. And when Edison invented the tinfoil phonograph, he went to Bergman to manufacture those. That was a very expensive novelty. They didn't sell a lot of them, and today a Bergman tinfoil phonograph is a pretty serious. It's on par with this for a phonograph collector. So Bergman, Edison, and Edward Johnson, who was president of the Electric Lighting Company, were third partners in Bergman and Company. Bergman sold his shares back to Edison and Johnson in about 1888 and moved to Germany and started the Bergman Electric. I don't know the exact name.
Right.
Made all the fans.
I mean, Bergman fans, and interestingly enough, in the 1880s, or 1890s rather, the Bergman fans sold in Germany were based on interior conduit insulation, spray designs, in terms of round ball motor, the casting for the AC series wound motors. They weren't induction motors until a little later.
We'll look at something special in a second. There is an interior conduit catalog sitting over there.
Oh, I have to see that.
That actually belongs to our shout out to friend Glenn Amon, if he's watching. I'm borrowing it now. Maybe one day let me buy it from him. But it lists, the interesting thing is Edward Johnson was the president of that company. So it all ties together.
It's amazing. I mean, this kind of dynamic of, transatlantic technological and cultural exchange. Not to sound academic, but I mean, a guy coming from Germany to New York, bringing ideas over, and then vice versa, ideas from the United States going back. And so this kind of very deep connection. I mean, you can see a similar thing with Tesla's training in Europe. I mean, the impact of guns, Starsa, companies like that, and, his experience with early AC, was something that was more popular in Europe. We can look at Rome, electrified by AC in 1885. Sure, we had Stanley working on such things here in the U.S., but not to the same extent. So.
To this day, and a lot of people don't know this, in my line of work, we work with lighting a lot, Europe is still ahead of us. In so many cases,
really?
Lighting technology in Europe is still ahead of the U.S., and it's been that way from the beginning.
That's amazing.
And it's unfortunate how little Europeans get credit for. And not even just Joseph Swan and the light bulb, but in power transmission, they were really more progressive than we were in many cases. So AC, Bergman Dynamo.
We can look at Wi-Fi networks too, and 5G, all of that. I mean,
yeah,
certainly other countries.
Yeah. But we're really good at developing things here and perfecting them, but we don't always come up with the idea.
The implementing them is the key. So, and here I see, now here's one of my favorite machines first. I love these Thompson Houston machines are just structurally just so unique. I mean, you have these pieces of rebar essentially that are threaded into a cylindrical, so to speak, and a bipolar construction, and in the middle of it, this cylindrical kind of ball-shaped rotor. I mean, but it's interesting how early in the 1880s, and we see this in a variety of technologies, a whole variety of design parameters came about. From the A-frame grenade, which was 1870s, the cylindrical design, monopolar construction, but by the early 1890s, almost everything was a bipolar construction, very similar to the Edison.
Right, and I don't think there was a bipolar prior to this. I'm not sure.
There was a Wallace Farmer experimental piece from the late 1870s.
Well, actually, the Wallace Farmer plating dynamo, the little joker.
Yes, but even prior to that, there was a Siemens piece, which was a bipolar construction.
Scratch that, Edison didn't invent the bipolar dynamo.
Late 1860s, I believe. But we can go back years. We can go to Jedlik's, the Hungarian inventor's electrical motor in the 1820s, which wasn't really it did have two poles, I believe, so not a bipolar in terms of visual construction like this, but operating on the same principle. So heck, 1820s, so almost 50, 60 years prior. But Thompson Houston was one of the many companies that was absorbed into the Edison General Electric, I guess we could call it
General Electric.
General Electric, right? So the big, corporate conglomerate that absorbed Thompson, Houston, Stanley, Edison, and later companies like Hot Point, DC Hughes Electric Heating Company, on and on and on. Northern Electric Company in Madison, Wisconsin, which was just a small local maker of DC apparatus. So, but from a visual perspective, this is one of the coolest machines ever. Just so strange looking and off the wall. But Chad, of course, is more interested in collecting things that are part of a broader story of lighting and power transmission, not simply discrete motors or dynamos on their own. I think you're interested in the whole systems of power transmission.
So that's the key to a piece like this in my collection. By the mid-1880s, you had companies coming out making light bulbs that were just generic light bulbs. There was an opportunity to make a product and sell it, and they'd make every voltage range. They put the different systems bases on them. But the companies that actually developed the system from the start, and we don't even think of things as proprietary electrical systems anymore, they were proprietary. You bought into a Thompson Houston system, or a jurisdiction did for Central Station. So they'd have a central station with 10 of these, all driven by steam engines or whatever force, mostly steam. And if you lived in that jurisdiction, you were using a Thompson Houston system. The sockets, the fixtures, everything.
Exactly. I mean, you could be using a Heisler system, you could be using a Mather system, any of these makers that were making proprietary stuff. But interestingly enough, not all of them were making their own light sockets. Bulbs,
A lot of times something like the bulb and socket by the mid-1880s was fairly standardized, and there was no there wasn't a lot of major development coming on until you hit the turn of the 1910s for metal filaments. So they make their own dynamos, they make their own meters, something that they could sell as being unique. But the bulbs and sockets were something they would outsource.
So tell me about this insane light fixture right there.
So that is a later fixture. We know that it's certainly of the period. It's not a Bergman. It would have very distinctive forms up here.
Yeah.
What's interesting is, anybody can put a socket like this on a fixture, but this has something called a Bergman push-pull on it, where when you push this guy in here, it turns the lamp on, and when you press that, it pops it out.
I've never seen that.
Yeah, we'll look at one outside of the fixture, but all of this is proprietary to work with that socket. In fact, this socket has an extended plunger on it so that you can reach it on the outside. So this would date to about 1888 to 1890. But it is fitted with all intact filament period Edison light bulbs.
What's the provenance? Do you know what house it came out of?
No, it actually showed up on eBay.
But was it here in the Northeast?
To be honest with you, I don't remember. I'd have to look.
Because it seemed like there were clusters of these items, say, in the Northeast or the Midwest, where you had larger groups of, power transmission systems in use, even in small towns. Whereas out west, for example, you wouldn't have seen as much of this stuff as you would have in the more industrial areas that were more apt to adopt electrical technology sooner, at least from what I can tell.
Yeah.
In Baltimore, I'm sure had a lot of these in some of the grand homes.
Yeah, Baltimore had installations certainly going back to 1882 are the earliest records.
Yeah.
Unfortunately, due to a major fire in 1904, I don't know of anything that survives of an original electrical installation.
And here we have a few of the Bergman lamps. Maybe you could show us.
Right, so when Edison designed or came out with his system, there was really nothing. He had to develop everything from the fuses, the sockets, and amongst other things, they made table lamps. John Vail, who worked for Edison, starting at Menlo Park, actually designed it. There's actually a patent for it. It's printed out right here. And interestingly enough, we have a picture right here of J.P. Morgan's office, and if you look at the desk right there, if you can see that there, guys, it is the exact same lamp as here. So J.P. Morgan was one of Edison's earliest investors. Of course, he had an Edison system at his house before anybody else did with his own isolated plant, I believe 1881, and he had that lamp on his desk. This is an interesting example.
He had the exact model, or this very lamp?
No, the exact model. Not
no,
this one. We have no way to prove that. However, this was found in New York. It could be, but chances are slim.
It's interesting. I have the Bergman fan of the same period.
In the base.
The base is
the
same.
The slate or whatever you might call
and
that.
A shout out to Roger Boutniol for finding that wonderful piece somewhere.
Yeah, well, that base is exceedingly rare. The whole thing is exceedingly rare.
Yes.
So this is a really unusual version of the lamp. It's thought that this is probably one of the earliest examples with a wood base. If you look underneath, you'll see that this very much is original and not something that somebody's made up. It's just the design is a little bit more bold, and I have reason to believe that this is one of the earliest examples of this lamp. We know that this example certainly existed by 1882, so this is possibly, we would say, circa 1882.
Well, I think in here you may have the crown jewels, so to speak.
Yeah.
But since we're doing really early stuff, the early 1880s, maybe it's worth doing that. I'm gonna go grab my drink really quickly, so I'll be right back.
So we're going to open up the safe here, where some of the...
Anyone who keeps light bulbs in a safe is a very serious light bulb collector. But I think there's real value in that because these are fragile. I don't think I could fit fans in my safe very easily.
Get the Bergman one in there, maybe.
Yeah, I could. The Bergman, the Iceberg, and the Union, and the Tesla.
We're going to just grab a picture here. So before we start this, we'll just give a little background on where a few of these light bulbs we're going to show you came from. So in late 1879, a gentleman by the name of William Hammer came to work for Edison. And he was really one of Edison's top assistants. And in the early 1880s, he traveled throughout the world to represent the Edison system internationally. When he did that, he collected examples of all of Edison's competition from everywhere, including, of course, examples of Edison's work, many of which were given to him by Edison right off the laboratory bench at Menlo Park.
Oh my gosh.
In 1904, he displayed the collection for the first time at the St. Louis World's Fair. And we have a little barking dog here. At the St. Louis World's Fair, and built these display cases for them. The collection was then sold to Henry Ford. There's a little discrepancy of if it was sold to GE and then Ford, but there is a surviving letter from William Hammer to Edison stating that Mr. Ford's being very cheap on his offer for the collection. However, he did wind up getting it. In the 1940s, a good portion of the Edison collection, portion of the collection, were given or sold to a collector from the West Coast by the name of Ward Harris. And Ward Harris really was one of the first collectors of Edisonium ever. He was able to get several or many lamps from the Hammer collection.
So we're going to see, for example, swan lamps. We're going to see early Nernst fixtures, which aren't even incandescent.
Right.
And then I'm just looking right
Sawyer Man.
Yeah,
the rarest of the rare. The earliest Edison platinum burning lamps that are just...
what about the incandescent experimental lamps that came before Edison, the few that were tested out? Are there any there?
No, he would not have had anything like that. The earliest he would have had would be Sawyer Man from the late 1879, 1880, and the earliest Edison platinum burners from 1878, 1879.
So if I'm not mistaken, I'm no expert on lighting like you, but I believe the two obstacles were obtaining a vacuum and finding a material that could, sustain exposure to long periods of burning under electricity, and that also was, I guess, a third factor would be luminous, when hit with electricity.
But in many cases, Edison was the one who really understood that he needed a high vacuum. That was really kind of part of the secret to his success. And in so many cases, materials that he had used prior to obtaining a high vacuum actually proved to work, even though they didn't work for him early on, such as using a metal as a filament.
I mean, because if I'm not mistaken, correct me if I'm wrong here, but I think 1809, Sir Humphrey Davies had an arc lamp that was on display in London somewhere using voltaic piles to...
Yeah, what they describe as being that is him basically holding two carbon rods
gosh.
together, but I don't...
I saw the pictures in the
changed.
history books as a kid, with this perfectly done little glass envelope with two carbon rods and contacts, and probably very far from the truth.
Right.
I mean, it's almost like one of the earliest electric heaters Moses G. Farmer worked on, I think it was sometime in the early 1860s, was just a carbon block with two terminals on it.
Right.
That he cooked a steak on.
Yeah. Right.
That's pretty brutal and unsophisticated, but it showed the idea, it showed the concept. Using the carbon piece to heat.
So when Ward Harris passed away, the majority of his collection was given to what became the Edison National Historic Site in New Jersey. His son kept about 10% of the collection and several light bulbs, and those have descended amongst private collectors over the past 20 years, and thus there are about a dozen Hammer lamps in private hands.
And you were the proud owner of this studio.
7.
7.
So
you were truly a Vol mogul at this point. You're the mogul of light
Anybody
bulbs.
who gets that gets that. So this is the earliest light bulb in the collection.
Oh my gosh, is that 1879 or 80?
Well, this is not 1879. This is 1880. Trying to get a whitish colored background behind here. So this is prior to going to bamboo. So this is a paper filament lamp. So The original display card that would have been with this is no longer present. However, this tag here that states Edison lamp with special hairpin filament treated with hydrocarbon gas and with special clamps, made in 1888 at Menlo Park, New Jersey, from T.A. Edison, signed William J. Hammer. So this is an experimental paper filament, Edison's first successful filament lamp that was used as, this is a prototype that was used at Menlo Park until it expired, of which Edison then gave it to Hammer for his collection.
Now I have to just touch it. I'm not going to pick it up. Just I have to get the good juju off of this. Oh my gosh! I've touched the most historically important light bulb I've ever seen. Picked it up just a little, not even a quarter of an inch off the ground.
So from there, we'll go to. From here, Edison had a working light bulb, but the Bristol board, which this was a paper, a carbonized paper, like a almost the weight of like a manila folder.
Yeah.
That was carbonized. From there, Edison really realized he realized he had to get away from something that 100 hours or so is just not going to do it, and they were really not transportable. This is interesting here. This is the remains. From somebody likely there of an early Bristol board filament outside of a bulb, but most of it's no longer around. So we'll get an afterwards.
And was that put together by Hammer himself?
This piece?
Was that handwritten by Hammer?
We don't know. It came up at an auction recently, and there were many things that were clearly from files of Edison employees.
I'm going to make a guess. Not that I'm a light bulb expert, but is that a Maxim lamp right there?
That is a Heisler.
Heisler. Oh, God.
I'm sorry. That is actually a Bernstein. Sorry.
Okay, but isn't there a Maxim lamp that has a similar design to that, or not? Have I totally butchered that?
No.
See, I had to ask.
We'll get to Maxim because there's some nice Maxim represented.
Right.
So this is really kind of a cool piece. It's an unfortunate. There's actually two pieces in here. But Edison's first chances at a successful lamp were he realized that the carbonizing of paper was too prone to breakage because it being so brittle and carbonized, but also inconsistencies and weak points which created high resistance, which would burn out. So from there, he knew he needed something that was more fibrous and would be stronger, and he thought that vegetable-based fibers would be a likely candidate. Ultimately, he found that bamboo was very successful as a filament when carbonized. And in many cases, the lamps were broken when they were, the early experimental lamps, when they expired, they would break them open, and somebody thought to save this, we need a little better conservation here than tape, and that'll happen eventually. But there is the laboratory experimental number right there.
And how many people did Edison have at any given time working on filament technologies in the late 1870s?
By this point, Edison would have had in a range of at least 75 people working
at one time.
Yeah. Menlo Park was a lot more than just a laboratory. There was also a library and office building. There was a machine shop. We can show some original photographs that survived right here. So there was a lot going on. I'm going to have to take over the camera because our cameraman has to go on the.
I'll take it over.
Okay.
In fact.
Yeah.
So
stop yours.
Can you just hold both of them?
Sure. Let's make sure I'm doing it right, and we're gonna just let
I'll
Mr.
rotate it so that. Yep, you're good.
Is it right here?
You're good. Just leave it.
You can't turn your phone while recording.
We'll eat it. Good.
Okay. So.
Thank you.
Well, I'm gonna film Mr. Shapiro.
All right, so now we're getting back to the Hammer collection. We'll talk a little bit about sort of my history in collecting. So when I was a kid, my first mentor in all of this was one of the earliest light bulb collectors after William Hammer in Baltimore named Dr. Hugh Hicks. And as a child looking in at his display of early Edison light bulbs, stand out of the light, the most important and desirable pieces to me that I saw there were his first screw base Edison light bulbs. And looking in that case, I remember like it was yesterday, it was 20 some years ago, and imagining if I could ever even just touch one. I get chills just thinking about it. So this is one of the wood-based Edisons from the Hammer collection.
Oh my gosh! Wow.
For a wood-based Edison, it's about as good as it gets. This one does still have the original card, which states that this was presented to him by William Hammer by Francis Upton. Francis Upton was, you could say, third in command at Menlo Park. He was originally Edison's chief mathematician, one of the few college-educated workers at Menlo Park. He eventually went on to run the first lamp factory at Menlo Park, which was recycled from the electric pen factory, which they had moved manufacturing.
I know a little bit about that.
Yeah, they had moved that manufacturing to New York. I believe Western Electric OEM did after Edison made them on site. So by this point, Upton would have been running the factory that made these, and a lot of times people call this the first commercial base. I would say this is really considered still prototype.
Let's take a closer look at it without the card.
Well, we'll pull out another one that isn't mounted in the base. One thing that's interesting about these is Hammer, these wood bases are not original. These are circa 1904 when Hammer prepared them to be exhibited for the first time. And he mounted the bulbs in these bases with either plaster or sealing wax. Had just anybody done this to one of these, it would seriously affect its value and importance. In the case of William Hammer, it changes everything in a positive way.
Oh, for sure.
So this base really never made it out of Menlo Park. It was used extensively at Menlo Park in houses of employees of Edison, Edison's home, Francis Upton's home, Charles Batchelor's home, all throughout the street lighting in Menlo Park. So these were used extensively in Menlo Park, but never actually made it to a commercial installation, which didn't happen until early 1881 at the Heinz and Ketchum factory in New York. The first Edison installation was the SS Columbia in 1880, but that originally used the Bristol board filament lamps. They continued to use a slip-in base that wasn't a screw base on that ship after, but they were still recycling those bases with newer lamps when bamboo filaments came out.
Well, let's see another probably 4 or 5 really key lamps from the safe, and have you go over them in some depth. It's just amazing. I remember when I was first got interested in electric fans, I'd always hoped that I would find an early electric fan that had no cage. Little did I know that I would find dozens upon dozens of electric fans that had no cage. I think there was a combination of enjoying the primitive aspect of a fan that had no cage and thinking, gosh, that's something really scary that could cut a finger off.
Right.
As a 7 or 8 year old.
Safety was a different concern.
Yeah, for sure.
For all of this. All right, so we'll pull this out in a second. This is kind of a nerve-wracking one, but it's important to show.
Why is it nerve-wracking?
Because it's really, really delicate. It's the only one in the world.
Okay, okay.
So much of what Edison did was a marketing, pomp and circumstance, showing off the power of his new system. And in many cases, they made some prototypical light bulbs that never actually went into production. This particular example, this is a religious symbol. It's not.
Oh my gosh, that's probably visually one of the most stunning bulbs you have.
Yeah.
And I've seen pictures of that, but here to see it in real life.
So I'm not going to take my hands off it because, again, it's a little nerve-wracking.
You're afraid that there's like wind or air that's going to be inside the building from the vents knocking it over.
So this was actually designed to be submersed upside down in a vessel that mounted on a bracket off the wall of a mine. There were rubber coated or insulated conductors that would touch these conductors here on the bulb to bring electricity to the bulb within the submerged water installation. And the idea was that in a mine where there were possibly explosive or flammable gases, if the bulb should crack, expire, spark, etc., and possibly cause a fire, the water would quench it. So this was shown in 1882 at Edison's exhibit at the Crystal Palace Expo, as stated there. In fact, the Scientific American that shows the report of that installation shows a drawing of this as it was installed. So yeah, this is the only place in the world you can see anything like this.
You rival the Smithsonian.
Oh, thank you. We try. Not that it's a competition.
But I want to get a good view of that because I think it's getting blocked by the light, so I'm trying to come over here to the side. Look at this. It's just the form of it. I mean, it is like a religious artifact. And let me put it on, move to your phone also, so we have a good view.
The other thing is we talk about sort of the Smithsonian and you know, just to bring up private ownership. And you know, in many cases, nothing against the Smithsonian. It's an incredible institution, incredible museum. But if any of you out there wanted to see what's in their collection other than the few pieces on display, it's nearly impossible. In proper private hands, so much gets shared amongst collectors. Anybody's always welcome to come here and set up an appointment to come see the
And right by
collection.
Baltimore, I mean, if we think about it, Hugh Hicks, the most famous light bulb collector probably of the latter half of the 20th century. I mean, after, of course, the Hammer collection. We're here in Baltimore, kind of the birthplace of...
Kind of a tradition.
Okay, we're back. So...
All right, we're going to put this one away. This, as I said, this one's a little scary. I'm going to show one more hammer lamp, and then we'll get into something that's probably, despite all that we've seen here, in relationship to even what we're doing right now, one of the most important light bulbs in the world, which few people ever get the opportunity to see. All right, so Edison's first installation of a central station, a lot of times is credited to Pearl Street in New York, which was first fired up September 4th, 1882. That is not his first installation of a central station. That is the first in the U.S. His first installation was at the Holborn Viaduct in England in January of 1882. And, excuse me, it was more of a test bed, testing the waters. It probably was a good idea. They didn't have Facebook back then. If the plant blew up, and it wouldn't have been good for reputation, it would have taken a long time to get here, or longer. William Hammer assisted Edward Johnson in setting up that central station, and William Hammer was the employee who threw the main switch and lit the 3,000 light plant. This is the bulb that William Hammer saved from that installation. Unfortunately, the tip is broken off. In a 1904 existing photo of the collection, you can see the tip is broken off on this bulb. So this could have happened while he was carrying it back. But regardless, this is a light bulb used at the lighting ceremony of the first central station for incandescent lighting in the world.
Oh my gosh. What's so nice is that this collection is not just driven by a desire to collect beautiful artifacts, but to tell a story historically.
Yeah.
I mean, you have the mind of a historian in a sense, and I
Yeah,
think that's really good.
These items, in many cases, become, again, we're not talking about monetary value, they become more valuable historically when they're amongst other items that they relate to help, as you suggest, tell the story.
Yeah, I mean, for me, fans do tell a story, too, of power transmission. I mean, the switch from DC to AC, the development of the induction motor, stylistic changes. But what blows my mind is that something as seemingly simple as a filament, a base in a glass envelope can have such variety and form and create such a variety of visual effects.
Yeah.
I mean, it's amazing.
Yeah, a lot of these objects they're beautiful. And
They're beautiful.
We've lost that today from manufacturing techniques.
And these are American made.
Yeah.
Or European made.
Well, this is actually made in Menlo Park, and it's even stated here that it was made at Menlo Park.
And you name your dog Menlo after
Yeah, Menlo. Well, yeah, Menlo. Menlo is right here. This is Menlo.
Named
Bark.
after Menlo Bark or Menlo Park.
So Menlo is about 6 months old, newest member of the family.
A pug. My kids are begging for a pug, but I don't know if that's going to happen anytime soon, but maybe I'll give them a light bulb instead and make sure they don't break them.
Not this one.
No, not that one. I don't think I'd trust Mason or Olivia to play with that.
Edison did start a manufacturing plant in Paris. He sent Charles Batchelor there, his right-hand man, in late 1881, early 1882 to start a manufacturing plant. And by late 1882, they were manufacturing Edison light bulbs in Europe.
Let's see the base. Let's see the base without the card in front of it for a second. Wow.
So this is what's known, what we call as a plaster collar. We can show quickly what that looks like outside of the base. So again,
no, this is a candy store of light bulbs right here.
So this is the first. When we get over to that case, we'll go over the development of the Edison base. But this is the first form of the Edison base that has a center contact, standard size threads, and you can screw this light bulb, which came out about September 1881, into a light bulb socket of today.
Right, and that's amazing. So that's 139 years old, and the concept of the screw-in light bulb is still with us very much today. Now, I don't want to drop these phones on these light bulbs.
Yeah.
So let me figure out another way to position these so we can both look at them.
Well, we're going to go to one last light bulb from the safe.
Okay.
Just really, well, it's two of them.
I think I'm going to position myself here because I felt, oh my gosh, do not want to lose grip on my phone over the greatest light bulbs in the world.
So,
collecting light bulbs, early on in my collecting career, I have to admit I broke a few, but thankfully nothing of any value.
well, we'll show this real quick. We'll wait. Let's stick in Edison. So, by the time Edison had a reasonably long-lasting light bulb, they started to notice that the inside of the glass envelope was darkening with use. And that was a transfer of the carbon from the filament to the inside of the glass. And again, I'm not a technically minded collector, but I know not to be dangerous.
Well, you're in the business of doing electronics and installation, so you do have a technical mind.
Right,
but you're not inventing them; you're installing them.
Right. But they understood that separation of the carbon from the filament and depositing on the gas was a transfer of energy. And in laboratory notebooks as early as early 1881, they were inserting platinum conductors within the lamps with a means of measuring that transfer of current. Again, I can't explain how. By 1883, there was a patent for an Edison lamp with a filament and a third conductor going into the lamp and a plate of platinum foil. They were trying to measure that transfer of energy as a use for a meter. If they could measure that transfer of energy, they could also use it to measure the usage of the draw of energy so they could sell it and replace what's called the chemical meter. We'll look at those soon, which is really crude, complex to use, and not very reliable. Ultimately, they never did. In 1884, at the Philadelphia Electro Exposition at the Franklin Institute, Edison had a display. He had on display many of his current at the time lighting apparatus. And he gave about a dozen of what are now called the Edison effect lamp to an English inventor, an electrical engineer by the name of William Preece. William Preece left all of his collection to, William Preece introduced these lamps to John Ambrose Fleming, who by the early 1890s was experimenting with what would become in 1904 the Fleming valve and the first vacuum tube. So in many cases, the Edison effect lamp is considered the grandfather of the vacuum tube and the grandfather of all modern electronics.
Let's see it.
In 1880, William Preece left his collection to a university in England. In late 70s, that museum or that university auctioned off those items, and they have since descended in private hands. So these are examples of the Edison effect lamps that were given to William Preece by Edison.
Oh my gosh, let me come in close for a better view.
We have a white background, might be better. So in this one, the plate is not between the filament. It is at the end of this extended tube. There are other Edison effect lamps in the Smithsonian's collection. I think Harvard has a science collection. It's either Harvard or Yale. It's Harvard. I don't know of another surviving example with this tube off the side with the remotely located plate.
Unbelievable. Well, let's move on to the some of the other apparatus briefly, and thank you for sharing the most important some of the most.
I have to show one more piece.
Okay, you do for sure.
This is probably my favorite non-Edison light bulb. It's not the most historically important, but it's special. This was designed by Charles Perkins, mid-1880s, and this is really the first four-way light bulb. One filament's broken, but this was designed where it's screwed into a socket that had concentric rings that these springs would touch, and these are 8 candle power filaments, and you could turn it on, and each turn of the key would ignite another filament for 8, 16, 24, and 32 candle power. So very, very wild. There are 2 known to survive. There's this one, and then there's the one in John Jenkins Spark Museum in, is it Belmore?
Is it Washington State?
Yeah, I can't think of it.
Outside of Seattle, I believe.
Bellingham,
Washington, yes.
So, pretty amazing piece. Interestingly enough, the Smithsonian has the socket for this, but doesn't have the bulb. Let me just flip it behind you. All right, so we're going to go over to the chemical meters.
Let's go over to the chemical meters. And let me adjust these, holding these. You know what? Maybe I'm going to have you
hold one.
Hold both of them.
Okay.
But make sure, and we're going to talk about them.
All right, so I kind of consider this a holy grail of electric transmission collecting. Would you, Stefan?
Oh, definitely. I mean, the idea of being able to monetize the transmission of power.
Someone says, please rotate your camera. Okay. This says you can't rotate your camera. I'm not sure.
Well, I think that's good. I think this is good.
We're going to stick with this because it works. Edison's first central station, which opened in September of 1882, they actually gave the power away for free. The technology was so new, people in many cases were fearful of it, and convincing people to adopt it was really, really difficult. They were more confident with open burning gas flames emitting CO2 into their house.
I mean, it's amazing today. I mean, if we think about that, I mean, gas stoves no longer have standing pilots unless they're commercial stoves. And even then you have a bypass valve because, hey, when gas gets blown out, bad things happen.
Right.
And electricity was thought to be, it's almost like 5G power network, or 5G cell phone networks today. You know, there's apprehension to a new technology perhaps.
Right.
That it's going to do something.
How dangerous is it? Will it cause cancer?
Will it cause cancer? Is it going to...
Yeah. We don't know. So this meter uses a process of electroplating. As the current runs through, it transfers deposits of zinc from one plate to another, which would be in a zinc sulfate solution. And at the end of the billing cycle, generally a month, they would measure weigh the zinc plate, and they knew where their starting point was. They knew how much weight transferred based on a kilowatt or whatever it was. Again, over my head. But anyway, and they'd measure it and they'd issue your bill. There are 2 jars because the accuracy was so poor that they would, if there was a major difference, they knew they had a problem. But in general, they would just average the 2. And in many cases, so this meter we're looking at now is a number 1 model. This is rated for 6 light bulbs, which is not a whole lot.
But at that point in time, that was a whole lot.
That was a lot,
because
yes.
Things, I mean, keep this in mind. Prior to the Welsbach mantle, lighting was far darker. Gas lighting and kerosene lighting white gas lighting was far darker than most incandescent lighting.
Right.
I mean, the Welsbach mantle solved that by creating greater airflow for wider, brighter light. But it was a difficult thing. I mean, they even added fans, spring-operated fans, to the basis of some white gas lanterns to make them brighter.
Burn more, hotter.
Yeah. So, it was very yellowish light, wouldn't you say, from these early light bulbs?
Right. Well, the color temperature didn't really change a whole lot. Certainly, a metal filament I think burned whiter. Today, now with LED though, we're trying to mimic this, and that's another story. Here's another chemical meter. This one, number 2, is actually for a 3-wire installation off of a 3-wire central station.
Rotation is vertical but top up now, so I think you need to rotate the camera this way. Okay, like that.
Okay.
And it's gonna.
Now it says rotate your phone. You can't turn the phone while recording.
Okay.
Speaking of 3-wire system, this is an interesting piece. This is probably the ugliest thing in the collection, but this is a piece of what is called Edison tube, which was the underground conductor for transmitting power from the central station. You'll see there are 3 conductors. This is for the Edison 3-wire system, which came out in 1884. This piece was excavated from ground zero. There's much of this cabling, or tube as they called it, underneath New York City to this day. When the ground zero excavations were done post 9/11, they found Edison tube, and it was saved, and a few pieces were traded amongst private collections. So this is not only a piece of early Edison history; it also is a piece of ground zero. Kind of chilling.
Well, sitting behind you, I have to draw attention to something really important. This is Charles Brush was one of the earliest electrical engineers in the United States. Born in Cleveland, Ohio. I believe he had the house on Euclid Avenue, if I'm not mistaken. And Brush created a dynamo, of course, prior to Edison, but he made carbon arc lamps. He was very familiar with the work of Jablikov in Russia, who had the Jablikov candles, which I think, 1874 or 75, or am I?
I think it's 76, but you're in the window.
Within 2 years. So you had the Jablikov candles, and Brush was very much aware of that. And this is one of the earliest lighting systems you would have seen in the United States. I have a French made carbon arc lamp from the early 1860s, probably used for experimental purposes. But this was, 1878 or so? Or no, probably 1881 or so, 1880?
Someone's saying we might have had the video sideways a lot. I don't think we actually did, but I think that's... Not sure.
Sorry.
Anyway,
We're not
sorry.
technically...
Yeah, rotate your monitor or your head.
Yeah, for sure. So anyway, one of the concepts here is that you have 2 carbon brushes, 2 carbon rods, and you can, of course, lock one into place somehow.
It's out of adjustment.
It's out of adjustment,
yeah.
But essentially...
It would automatically regulate.
It would automatically regulate with clockwork mechanism, and you have... 2 carbon rods, and you're going to have an arc, kind of like an arc loader, that generates a very intense light. Now, of course, for home use, this wouldn't be the most effective thing versus an incandescent lamp because the lighting was too bright, too
harsh, yeah.
And alien-looking in many ways. But here we have one of the earliest forms of electrical lighting, which is actually more powerful than incandescent lighting, but had other issues.
Too powerful in many cases.
I mean, you stare at it like staring at a mercury vapor lamp. It's not very good for the eyes.
Right.
And they even used the same technology as like this in the 1940s and 50s to create sun lamps for tanning purposes.
Yeah.
So, I mean, it's a technology that's from 1809 to 1950. I mean, my gosh, that's 141 years old. Kind of like the screw base.
Yeah. So one of Charles Brush's major contributions to, like Stefan was talking about, his clockwork-driven arc lamp. That advanced the carbon based on time, driven by the clockwork and a governor.
I hate to tell you, I don't think he was the first to do that.
Yeah, maybe he wasn't, but he did a good job of it and made a lot of money doing it.
He did a very good job of it. I mean, I think the one I have...
well, but this isn't a clockwork. That's the difference.
This isn't.
So brush, the brush system, yeah, if you look at this ring here, that's right here.
This is manually advanced.
No, this isn't manually advanced. This ring, this mechanism, and there's a patent for it, was what advanced the carbon rod, and I think we probably have some very, very knowledgeable arc lamp collectors maybe watching that know more about arc lamps, but the advancement of this rod was based on the need for advancement based on the consumption of the carbon. which was a low maintenance, which was needed for commercial use.
The arc lamp I have with the early 1860s patent, is it a debris or debris?
Something like that. Yeah,
I can't pronounce my French words, and I like watches, which is not a good thing for someone who can't pronounce French words, but I think it's a debris from the early 1860s, which does have a clockwork mechanism.
Yeah, and most of the European units that would predate this did. That was one of Brush's, and maybe others. I think Wallace had an auto advance as well. This is a focus lamp. The lamp that Stefan's referencing that's French is also a focus lamp. This could have been used in a magic lantern, was a very common use.
Or a university classroom.
Right. So in that case, a clockwork mechanism was fine. But once you were suspending this in the air for street lighting, you needed something that would auto advance, and that was really one of Charles Brush's big accomplishments.
Well, I see the real filmmaker has come in. Is he available to operate the camera again?
All right, we're back to a professional.
Professional.
So we'll go to this dynamo in a second, but we'll just quickly brush on these meters.
Brush on them.
We'll brush on them.
Yes.
So this meter here is really quite special. This was the first meter to give a direct reading. So the whole process of having to remove plates from the chemical meter, deal with caustic chemicals, well, messy chemicals, have to then go back and weigh them and issue issue an invoice. With this meter, there was a direct reading. This cover here would have been over top of this, and it would have had a lock, and a window would open, allowing a meter tender to come and see how much energy was used. This was designed by Elihu Thomson in 1888. It was replaced by 1889 with Elihu Thomson's own design of the rotating disc meter, which up until the smart meter today is a technology that has pretty much sustained. There are two of these known to exist. There is this example, and then the example in the collection of the Henry Ford.
Oh, wow.
Museum.
I mean, this caught my eye. I'd never seen anything like that. I mean, when I first came in here today, just to see this for the first time, this blew my mind. And I didn't realize the significance of it.
This is referred to as the walking beam meter. So the current causes this whole assembly to rock. There's a little pawl that each rock advances a gear, which drives a clockwork mechanism. And then we have the Shallenberger meter. This is the first meter produced for measuring and recording AC current. So this is for the Westinghouse system. So really, really important meter based on the ability to start powering the country with AC and collect money.
And it's a Westinghouse product out of Pittsburgh.
Right.
I mean, because of course everyone knows the famous or infamous battle between GE and Westinghouse, but of course GE was adopting AC by the time they were GE.
I like how you say that. GE versus Westinghouse. It's a lot more accurate than Edison versus Tesla.
No,
Not as dramatic, but it's true.
But it's the truth. I mean,
Yeah.
but ironically, even though everyone says, GE was such a DC-based company, I mean, they had one of the earliest induction motors on the market by 1894 with the Linworks pancake fan. I mean, 5 years after Tesla's induction motor was sold by Westinghouse. But even so, they were designing and marketing AC equipment in the 1891.
92 was when,
92,
mid-1892, I think about April was when GE was formed.
But they were selling AC stuff from the start.
And I should say, it wasn't really GE versus Westinghouse. It was Edison versus Westinghouse, not Edison versus Tesla. Edison General Electric, the precursor, did not use AC. Once Edison was removed from the reign, GE knew what they needed to do, and they proceeded with a DC system.
Now, I've had Shallenbergers in the past. I don't think I fully took the case off. So what is that strange moving? I mean, I know it works in many ways like an electric motor, moving and recording the power use. But
Are you talking about the blades?
Yeah, the blades.
I believe that is basically a simple governor. So that was just in catching air would control it to not spin out of.
And maybe it would cool it. Maybe
it
would cool it, because I would think with the windings there could get a little warm, possibly.
Yeah.
I mean, almost like a primitive cooling fan in a sense.
Yeah. It's a fan. It's an electric
fan.
It's
a fan. It's a Westinghouse, and I like Westinghouse more than GE. So there we go.
Well, so let's move on to something pre-GE.
Yeah, that's a controversial statement among fan collectors. But Emerson's best, I have to say.
So this is about an 1887 Edison Dynamo, 20 kilowatt, would have run about 200 standard.
It's Edison Machine Works.
Right, so this is Edison Machine Works. So the earliest of Edison Dynamos were manufactured by the Edison Machine Works. Originally started on Warwick Street in New York. The first machine we looked at was a Warwick Street Dynamo, one of the very few surviving Warwick Street examples in a private collection. We're talking two,
Right.
Maybe three. This was made at Schenectady, so in 1886 Edison moved to Schenectady when he needed more space. He found a no longer used locomotive manufacturing facility, and he bought them and moved his machine works there, and that is the birth of Schenectady as being really the headquarters for decades of electric lighting.
And if I'm not mistaken, George Westinghouse was born somewhere in upstate New York too, probably within an hour or two of Schenectady.
Yeah, ironic.
Ironic, isn't it?
Yeah. So this is also another machine that was in Henry Ford's collection. Henry Ford bought this machine in 1928 from a power company in Rhode Island. It was on display in their offices as a relic at that time. And in 1985, when they decided to clear some of their storage, this was offered for sale.
Stunning. I mean, and it's all. I mean, you can see maybe at some point someone had a little fun with the black paint over the red paint. But
No, the red is actually a primer.
it is.
Yeah.
I've seen these.
You'll see it on there as well. Areas where.
But
it's
I have
more-
like maybe I'm imagining it, but I believe I've seen an original brick red.
Oh yeah. That's
I
another.
think I know where that dynamo is.
Yeah. Well, that's an exhibition example that has some.
But it's the
additional-
same red that you see underneath this primer.
It's darker.
It is darker?
It's darker. It's
But the
more like a
pinstripes
maroon.
are really amazing on
Yeah,
it.
that's a special piece. Hopefully it arrives here one day. I've tried. There's a cool shot we could just show. This is blown up from a photo album of original photos from the Edison Machine Works. And there's a little bit more of a reference of what this guy would have looked like installed.
And what was the largest size in terms of kilowatt? Was it 80 the largest?
150. So the
Who was the
150.
one that was that, did Keith Blay know about the 80?
That's the 80.
Have any 150s shown up?
No, there is. I have a picture of one in storage at the Henry Ford Museum. It's
So
big.
it's still there.
It is still there. Yeah.
Well, good. So there's at least one in existence.
Yeah, there is. And when you look at pictures of a machine like that in reference to the people standing by it,
It's probably as high as the ceiling, right?
I believe the dimensions listed on that machine. I believe it's 9 feet tall, so you have the height of the ceiling, like 12 feet deep and 8 feet wide.
And how much does it weigh?
If an 80 kW weighs 17,000 pounds,
40?
let's say in that ballpark,
40,000 pounds.
yeah. Imagine moving that before, in
But
1885.
But even then, it wouldn't have been that big compared to all the huge cordless steam engines.
Yeah.
I mean, just
Yeah.
imagine that, or locomotives and
Yeah.
things that were.
Yeah, and easier to
massive.
take apart and move, actually.
Right, you could take the fields apart.
Yeah,
and-
yeah. Oh, there are surviving photographs of these machines being installed one piece at a time with block and tackles. So that's how they would have done it. This machine weighs in at about 3,100 pounds. So in the world of Edison Dynamos in the era, this was small.
Yes.
Today, to a collector, this is not small. It's quite heavy and cumbersome to move. This would have been small in back in the era.
So we should finish it by showing them the switches and your
Go
light
over
bulbs.
some light bulbs in there.
Yeah.
All right, so this is some for the lighting collectors out there. We saw earlier one of these ammeters over there. Here are some Bergman switches. Again, they had to invent the whole entire system.
I love the big that large one on the far left upper corners. Unbelievable.
They actually got bigger than that. That is a 60 light. I think they went up to 150.
Oh my! Have you seen a 150?
I've seen a 100. I know where a 100 is. So
I hope it's in the case soon.
it's not. I hope so too.
I hope it was
one
soon
day.
in the case, right?
One day. These are some early Bergman fuse blocks. So the interesting thing about this is this fuse, the earliest Edison fuses were made of wood. By the early 1890s, later 1880s, they really understood that wood was not a very good insulator, but very, very few. This did have a brass cap that's no longer present. Very, very few
But I remember
would fuse to
I
survive.
brought you to Wisconsin near Milwaukee, and you dug through a building
A bucket in a building.
and didn't you find one of these?
No, it was the shell for a socket. Yeah.
Okay.
Yeah. But this stuff is out there.
But you did dig through one in another undisclosed location in the Midwest.
Sorry. And we found that.
I hope we find that.
This was in a milk crate filled with a lot of much later
in an
switches.
unnamed house
Yeah.
of a fan collector, and he was absolutely shocked that out of how many switches do you think? 200 switches?
There were probably 50 in that.
Probably 200
Oh my
total.
God! Oh yeah, but in that one
milk crate, he
yeah.
pulled that out in amazement. He's like, "Oh my gosh, Chad is the light bulb and switch guru," and he knew. And didn't you have to have the key made? Wasn't that
The key was not original. The key here is not original. The key was not present. It had been replaced a lot of times over the years. Stuff like this gets modified and repaired. That was replicated and borrowed from another example of the switch.
So if anyone wants to eventually find a piece to include with their 1880s Crocker Curtis fan that would have been 110 volts, this probably would have been the switch on the wall.
Yeah.
Really, it's kind of amazing. I mean, look at how the patina's left. I mean, the one
This
thing he
actually
does
may be a
is,
little small. This is a 10 light, so it's about right,
it would be right. But what I like is that you've left the patina on pieces
Yeah.
of can. Of course, sometimes things have been polished up by all the old-time collectors who thought shiny brass was a good thing 30 years ago.
Yeah.
But they're starting to develop the patina again.
Well, yeah, you look at these guys, something like that. Somebody cleaned that.
Oh, they did. But it's give it another 10 or 20 years, and it's going to look
Yeah.
great again.
So more Bergman fixtures. These are
This,
the
so
swivels.
you have to. This.
Yeah, this is a
Unbelievable.
very early trouble light, drop light. People call it different things.
One of my favorite pieces here.
This shows up in documentation from 1889 as being approved for use by the U.S. Navy. It has an Edison General Electric socket, an early Edison glass
Look
plug-in.
at that. This is unbelievable. Now, that is the switch, or the screw-in socket we all need for our early fans. But there are not too many of these out there, do you think?
they're very, very difficult.
I mean, this is almost twice the size, the top of a normal one.
Yeah.
Or not, or one that we'd see from the latter part of the 1890s.
Which were much better designs, but this is, the more crude it is, the more I
But I
like it.
love the glass. I love
Yeah,
the green translucent sort of.
So, and the interesting thing about this is if you just look at how this is made with really, really fine precision threads, they didn't make things like that for this type of use very long. A trouble light like this would have quickly been replaced with just stamped out, cheap, inexpensive stuff. This is really kind of a special piece. So,
I mean, it's built with the same precision of, say, the early European and French motors, dynamos, and arc lamps, which are in many ways built like scientific instruments or clocks.
right.
I mean, with this level of precision. Even the company Breguet that made watches was involved in the manufacture
Dynamos.
of dynamos,
Yeah,
a watch company like that. I mean, so that speaks to the emphasis on precision.
let's talk about this piece quickly.
Yes,
if you had asked me a week ago, I wouldn't have shown this to you.
This is the newest
I had
edition.
it, but so this item popped up. Let's just get rid of the glare. This item popped up as being from the estate of an autograph collector. The plate says drafting set used by Francis Yale at Menlo Park in 1879. Francis Yale was one of Edison's early assistants. He stuck by Edison really to the end as far as a friendship and relationship, and really was the driving force under the direction of Henry Ford for starting the Henry Ford Museum and the incredible Edison collection they have there. When I inquired about, most people, you see something like this, myself included, question, what is this? Anybody can make this plaque. A drafting set like this really isn't all that rare.
Right.
Is it legitimate? Well, it turned out that the autograph collector whose estate it came from was named Rex Beasley. When I looked up Rex Beasley, I found that he had written a book published in 1964 on Edison, and I found the book online, hoped to find some mention in here of his relationship with Francis Yale. Well, not only does it discuss Francis Yale being, until his death of 1941, being a major influence on his collecting of Edisonia, On page 74, we have the drafting set here. These two pieces, this is a late commemorative piece. This piece, and a few tools are missing since, but it states here that it was originally presented to the author by Mrs. Francis Yale. So it's interesting how sometimes you find an artifact and it takes some effort to find the paper trail, but in the long run, in this one, it really paid off.
Well, next to it, you have a piece from me, but I want to tell you something. That came out of a collection near Baraboo, Wisconsin, Sauk City. It belonged to an old guy who just passed away 4 months ago at the age of 90, 5 months ago from cancer. And I found that. I found a Crocker Curtis serial number 752 battery fan motor for $250 the same day.
Wow.
Killer fountain pens, but to think all of this stuff came out of a small town, Baraboo, I mean, where the Ringling Brothers Circus started. But there was a lot of power plants up there, and obviously the CNC battery fan was, pre-central station use up there. It was a battery fan. But still, to think this stuff survives in the Northeast and the Midwest in attics. And
The stuff is still out there.
The stuff is still out there for sure. And you know what? Sadly, some people still think it's scrap.
Yeah. You wonder.
I mean, something
what
like
we
this-
have here is a tiny percentage of the
Right.
tiny percentage that wasn't thrown out.
Right.
You
I
know,
mean,
and it's happening to this day that it's being thrown
It
out.
is. I mean, with electric fans, especially alternating current fans, although there were scrap drives during the First and Second World War, if it worked, a lot of people weren't going to throw out a working electric fan they could plug in. But a light bulb would get broken. I mean, just to give you an idea of how much rarer some of these light bulbs are versus electric fans, they're so much more fragile.
Right.
So
in
it
many
took-
cases, I'm sorry, go ahead.
But it took someone who was who had a concerted interest in history to preserve and recognize the importance of that at that point in time.
Yeah.
And will a similar thing happen with electric vehicles today? Will there be someone who's saving the battery packs, saving all of these technologies that in 100 years are going to be seen as, groundbreaking, paradigm-shifting, technological pieces? Is someone going to do the same thing?
I think people are a little bit mindful today. Let's go.
We got to go over to Chad's favorite.
Let's do one more thing over here. There's some
Light
paperwork.
bulbs.
Oh, we're gonna look at some paperwork.
And then we got to go to light bulb.
Now we're gonna go to light bulb case. So these are just some items we put out of the safe. This is some of the first. This was dug up by the Edison pioneers in 1933. This is the first burial power cabling for electric lighting in the world, dug up from Menlo Park. This was run underground. There's a pretty good amount of documentation on how they made this with tar and canvas. And this was used to send powerful electric lights from the machine shop where the dynamos were to different sites in Menlo Park. We talked about the first Edison installation ever of electric lighting on the SS Columbia. There were 4 dynamos, 2 of them remain. One is at the Smithsonian, one of them is at the Henry Ford Museum. Charles Clark worked for Edison and was very much an archivist. And from one of the dynamos that did not survive, he saved some pieces, including this original winding. So, in the interest of time, we're going to show one document. We could do
one of Thomas Edison's signatures?
Yeah, so this is actually a sign. Try to get rid of the glare. This is a sign. This came from the estate of George Meister. I'll back up just a little bit. Who was the paymaster general at Orange, New Jersey. And when he left, he kept the sign that was on the door to his office. And this is it. So that is an Edison signature, and it's also
Keep out of this room.
Yeah.
Thomas Edison.
So it is a signature, and it is also from the laboratory, the later Orange, New Jersey laboratory. This is the nameplate off. We could do a whole hour just on paper and ephemera, but this is really one of my favorite pieces. So in this letter, dear sir, I find in my copy of the trust investigation that you have copies of the mutual boards of New York. I find in my copy of the trust investigation that you have copies of the mutual books of New York. As I'm about to give Mr. Kennedy a chance to show how cheap he can make gas by entering into competition with the electric light, I am very naturally desirous of ascertaining the mutual's weak point, if any, and the bottom cost of supplying gas. Could you and would you give me the data when you come to New York, drop in and see me? So Edison moved to New York to open his office in 65th Avenue in March of 1881. This letter is one of the first letters he would have written out of that office in 1880. And he's basically loading his guns to go up against the Goliath, the gas industry. So here's a guy who's 34 years old, doesn't even have an operating central station yet for well over another year. And he was preparing to challenge a huge industry, and to think that he was right, it worked. So pretty letter that's pretty special to me.
Yeah.
So.
Well, what blows my mind is over here, looking at this amazing variety of light bulbs, the colors, the shapes. You have, so what's the proper terminology for is that a bevel ring?
That is a Johnson bevel ring.
Bevel ring.
So so the first lamp here actually is based later, but would have been manufactured in 1880 with platinum vice clamps. The first Edison base after the wood base that was actually used commercially was the Johnson bevel ring. The bottom threads are one contact, the upper beveled ring is the second contact. They made that for about 6 months. There was a problem where the plaster that mounted the brass ring would fracture, and that's when they moved the contact to the bottom, and there you go. Move the contact to the bottom, and basically is the base we have today. I know a lot of people like colored lamps. Back up just a little bit. So these are 3 1884 to 1885 era Edison lamps in red, green, and blue. Those are quite rare in any form, but colored are pretty much impossible to find.
So are these the earliest lamps here, right here?
That is the earliest light bulb in the case. Well, no, actually the one above it's earlier, but that is one of the most important. So Joseph Swan was working on developing incandescent lighting in some stories decades before Edison. Unfortunately, the dates that are recorded get earlier and earlier and earlier, the more his family was involved in writing the history. So we don't know for sure, but he definitely was working prior to Edison, and his first installations of incandescent lights in Newcastle upon Tyne in England would have used that light bulb. So that is the 1881 Swan, is the first commercial Swan. There are 5 of those known to exist in the U.S. One is at the Henry Ford Museum from the Hammer collection, and the other 4 are here. And then we move to the later style Swan. There's a transitional form in between. There's one in the collection, but we may not have time to show that. Then we get to Maxim. So these guys, just show that one right there with the flame shape. That's a good one. So Maxim was Edison's chief competitor in the earliest days of electric lighting. He was even reported to have spied on Menlo Park, at which point they put locks on the doors. His company, along with Moses Farmer, United States Electric Light Company, had the first installation on land in the U.S. It was in a bank building that they actually leased the basement from for their operation. But Edison was first on a ship, but Maxim was first on land.
And are those glass stopper-based lamps below?
All the way at the bottom?
Yes.
Yeah, so these are the Westinghouse Stoppers. So in 1892, Westinghouse won the contract to light the 1893 World's Fair. The only problem was Edison, at that point, had won a patent litigation against pretty much everybody that basically said you couldn't manufacture a lamp with a fully fused glass envelope, platinum wires entering into the glass, high vacuum, several different points, but the most important was the one-piece glass envelope. So, all right, we're coming up on time here, but anyway, outside of light bulb collecting, even the Westinghouse Stopper is one of the most known early light bulbs that saved George Westinghouse's ability to light the World's Fair. These are 2 examples. The one on the right is kind of interesting. The stopper is actually milk glass.
I just love that. I just love the design of those.
Yeah.
So, well, I think we better call it time. But thank you so much for the opportunity to
Thank you.
You know, I can't shake your hands in the socially distanced era, so. Well, thank you guys. Much appreciated.